Hey guys, in this video we're going to talk about 12-volt refrigerators and everything that you're possibly going to need to be able to power them and keep powering them so you don't get stranded on the trails. So we're going to talk about power management, what different type of power systems to use, and how to hook them up, and what's probably the best and what may be the best for you. So let's dive into it. All right, so you're getting into car camping, overlanding. Awesome, I'm excited for you. But there's been a lot of questions about what we've been using to power our 12-volt refrigerator. 12-volt refrigerators, freezers are amazing for longer trips and excursions. You don't have to deal with ice, you don't have to deal with water. You plug them in and good. Obviously the ease of them is you plug them in, set your temperature, and you're good. And it holds that temperature. The power management, on the other hand, is something that most people need to think through before they go out for a weekend. Because if you just plug it in a cigarette lighter on your car, some cigarette lighters, when you turn the vehicle off, cuts the power off to it. So you have to have a way to be able to run your refrigerator. If it does stay on, if the power does stay on, it's a permanent on. Okay, then something you have to think about is having enough battery to get you through the night so you can make sure you can start your vehicle the next morning. And so that's where this video comes in. Let's jump into this a little bit here, a little bit more detail here, and talk about how we've got ours set up and a few different options. Okay, one option to power your refrigerator and your 12-volt accessories and even 110-volt accessories is a battery management system like a Bluetti. I have a small one here that we use. It's a multi purpose one. It's like a 3-in-1. But there's a lot of different manufacturers make them. These are probably the most easy for the average person to do because you can plug them up, you can plug them in a home, charge them up, and go out. One thing you need to be careful of with any type of battery like this is, one, does your vehicle have enough power to charge it while you're driving? Because of them, it requires a lot of wattage to charge up really quickly, and you got to make sure that your vehicle is capable of charging it. Two, additional to that, is your vehicle have enough charging capability to charge one of these when you're traveling from point A to point B through the day. Also, and to run the refrigerator itself. Some do, some don't. A lot of that comes down to manufacturer's specific and the size of alternator it has and the accessory ports that it has. This truck here has a 110 volt inverter on it, and so I can charge the smaller battery packs while we're driving and still be able to run a refrigerator through the day if I was to choose to do that setup. We've kind of went with more of a permanent type of setup with a 12-volt battery and a DC to DC charger. So that way it's permanently installed in the truck and it's ready to go at any given time, and it's at a full charge. So anytime I drive the vehicle around, it charges the batteries up and keeps them at optimal level. So let's dive into that here a little bit, and let me explain to you what we've got and how we did it. Okay, so guys, let's talk about DCDC chargers for a couple minutes. DCDC chargers will pull off the alternator on your vehicle as it's running. There's a couple different manufacturers that's really popular. The biggest one is Renogy. They make really good stuff, but they're also very expensive. We chose to go with a less expensive option that's been around for a long time as well. I think they're more based in like the solar industry, but they also make an outstanding DC to DC charger for like marine applications and also for like Gladiators and overlanding. That's Renogy. We chose to go with the 40 amp DC-DC charger. And this is great because this can work off solar, also works off the alternator on the vehicle. So I can plug this into solar panels if we want to use solar panels. If we have base camp set up, that'll charge the battery up when the sun's up, obviously. Or it'll also charge it up as we're driving down the road. This is the option we went with because it's a little bit less expensive than a Red Arc. Red Arc makes some great stuff, so not saying anything bad about them. This is what we decided to go with. This is a little bit less popular option, but it works great so far. This also has the capability of charging all the different types of batteries. So lead acid, gel, lithium, and so on. It covers the gauntlet. But how we have ours hooked up and wired up, I actually have the refrigerator hooked up on a gang bucks. I've got a 5-gang switch here that I can turn the refrigerator on and off as needed. I can turn the lights on and off as needed. I also have auxiliary ports here for extra options. I also have USB bungs here, 2.0s or 2.1s, so I can rapid charge, cameras or like our inflator for air mattress. I can charge everything while we're at camp. off the auxiliary battery, so I'm not pulling off the regular battery. But I can also charge them while we're going down the road, and that's where this gets into it. This is a great setup for us because it's versatile. I can turn everything off when we're not needing it, but the charger will still maintain the battery. That's one big good thing about the DC-DC Chargers is once the battery's charged, it goes into what's called a float mode. It's kind of like a trickle charger, like a 2-amp trickle charger that some people use for motorcycles, lawnmowers, and even automotive use. They'll kick on and off to keep that battery at maximum charge and optimal level, so the battery stays healthy and increases the life of it. So let me show you how I got mine hooked up here, because the charger itself, guys, it's kind of hard to see where I have mine mounted. There's plenty of airflow to go through to keep it cool, but it's kind of hard to see because I have it in the front of the bed. But let's go into it. But something else I want to talk to you real quick before we jump into that is you need to make sure that you prevent yourself from shorts if you're going to do something like this. Make sure you do your research before you take on this upgrade. It's nothing most people can't do. Two big things that you need to make sure you calculate is one, service factor. Service factor is the percentage of draw on a wire. So you're going to, depending on how long of a wire you're going to need to run from your battery to your DC-DC charger, that's going to vary on different wire sizes. I was able to get by with 4 gauge wire on this build here because my length was plenty good with service factor, so we're good. But something you need to keep in mind is what happens if there's ever a short between the two batteries, especially if you have one battery in the rear of your vehicle, one in the front of the vehicle. You can do this safely, guys, but you got to think through the process here to make sure that you don't cause a problem. So this is where it gets really important to make sure you know what you're doing before you do type of installation like this. And if it's something you don't feel comfortable with, hire a professional to install this for you so it's done properly and safely. But here, let's jump in here and I'll show you guys how I have mine hooked up and explain to you why. Okay, guys, so here we are in the front of the bed here. I want to show you what I did with this one here to give myself a little bit more insurance to make sure that nothing could ever short out, nothing ever have a problem. Did this in 2 different ways. One, I used a board here on top of the battery that's screwed to the battery box. This is an insulation factor between the relay and the battery. Also, the battery box itself is directly bolted to the deck system, so this cannot come loose in any way, shape, or form. I also have a ratchet strap that goes around this for the cover for protection as well, so nothing can get to this and short anything else. One other thing that I did this for and raised that up like I did, if something was to fall on this and pushes it down and collapses, this will actually push down and open this up to make sure that it doesn't short out. If something was to happen, these would get pinched. If this side shorts out, it's going to drop it out regardless because this is only a 50 amp circuit breaker. But that's one thing. Two, if there's a short between here and the front, the circuit breaker is hooked up to where it comes off the lug on the battery into the input of the relay, and so everything is directed out of it. So if there's a short between, both relays should drop out and mitigate any fire or any overheating of the wire. That's one of the biggest concerns that you need to think through and make sure you do it correctly when you do an install like this, because you can put a relay up front, it's going to drop that fuse out or trip the circuit breaker, but the one in the back, you got to make sure that this can trip as well, and so it doesn't burn your vehicle down. Okay, I'm not trying to scare you guys. I'm just trying to emphasize that this needs to be professionally done, and you need to make sure that you know what you're doing when you do it. So here I'm going to get the camera real quick, and I'm going to show you the relay. Okay, guys, here we are on the inside of the bed here. You can see how we've got this higher hooked up. Like I was talking earlier, this is the input side of the relay down to the lug on the battery for the positive. The ground goes straight to the chassis back here. It's also grounded at the front of the vehicle. So anything wants to short out anywhere back here post this, which is between the 2 batteries, it will drop both relays out and keep yourself safe. Also, I have Phoenix connectors here on for the input side from the battery up front to back here. Also have them for this here as well. The relays, as far as the gang box, are here. As you can see, it's a 6 gang. Also, it has fuses. So these are 50 amp circuits that are fed off this here. So if anything wants to overload here, it will trip out the relay before it does anything stupid up here, because I will never need to pull 50 amps off this at one given time. Also, we have a fuse box over here to handle all of our low voltage accessories, our USB ports and everything else. So if a fuse was to blow here, you know, it drops everything out, and everything is self-contained within this area to keep things safe and manageable. So let's jump up front here, and I'll show you how I have the front hooked up. Okay guys, here we're at the front of the vehicle, and obviously safety is number one. We want to stay as safe as we possibly can, and peace of mind and insurance policy while we're out. So, because we want to be able to get out and enjoy ourselves and not have to worry about can something go wrong. And so that's where prep and planning ahead of time really, really helps. Okay, so I showed you the back and the front of the bed, how I have everything wired up. I also showed the relay, you know, how it trips out. The one up here is typically bigger because the run between here and the back battery is a lot further. So you do need a little bit bigger of a relay up here. Go to OEM specifications for Renogy, Red Arc, whatever power management system that you're using. They will recommend certain amperages for each side of this equation. But how I have mine wired up here, I made a simple bracket here that the relay mounts onto. And then this is the lead going from the back battery and the charger in the back up to here. Again, if this was to short out between here and the back, it will drop this out just like it does in the back. And so that's a double protection on both sides. And theirs is just a short jumper between the end of that relay and the battery. The ground is hooked directly to the battery here. And again, it is grounded directly from this lug, like all OEM manufacturers, directly to chassis as well. So it's grounded onto the chassis on the front and the back. So guys, this is the easiest way I do it, and that way we're protected. We don't have to worry about overheating. If anything was to short out between here and there, you run over a piece of plate of steel, whatever, anything that may happen, you're protected. So that way it's going to trip out. But follow OEM manufacturers also. Just because I use 4-gauge doesn't mean you need to as well. You need to know how long of a run you're going to need to be able to properly spec what wire size you're going to need. Because if you underspec it, the wire can overheat, the insulation can melt, and the relays won't drop out. So make sure you run the right type of wire. So as far as how the system works, and as far as the building and float system, this requires a signal wire. And so the signal wire will either come off of solar. If you hook it into solar, it will automatically pull the signal wire off of solar. But if you go on DC to DC charger like we have this configured, you're going to need to run a positive wire from the signal from your DC charger to an accessory wire on your vehicle. So that way when the key is on and running, there's a power source goes back. It tells the charger that the vehicle's on and running. Then it's going to kick on and off and then monitor the battery level of the auxiliary battery and then charge it up accordingly. If it's low, it's going to do a rapid charge up to a certain point, and then it's going to kick down and start doing like a float, which is like a trickle charger. It's going to kick on and off as needed to maintain it, or whatever amp draw or whatever voltage draw that it's needed. Because as the refrigerator is running, it's going to need to have power. So that overcomes all that, plus it's still able to charge it. So let's jump in the back here real quick. I'll show you our LCD readout of the battery, and we'll start this thing up real quick, and you can see how it takes a minute or so for the Renogy to pick up that the vehicle's running and the alternator is charging. It will put a load on the system. The alternator will pick it up, and it'll raise the voltage, and it'll charge all 3 batteries at the same time. That's the great thing about these DC-DC chargers. So let's jump in the back, and I'll show you how it works. Okay guys, as you can see here, it's only showing 11.9 volts. That's because the refrigerator is on and it's pulling current. And so that's why it's not showing that it's over 12 volts. So as the refrigerator runs, it's going to trawl, which is going to show you a little bit lower of a voltage than what you actually have. So we're going to start this up real quick, and then you can see this thing, the voltage come up, and as this thing is starting to charge. So the vehicle is now started. You're going to see the voltage from where it was, and then you're going to see it slowly start ramping up because this vehicle does have a smart alternator on it. Okay, so now we're back up 12 volts, 12.1, 12.2. Now you're going to see this slowly come up. This thing will range anywhere between 12.7 and 14.5 volts because as it's charging, it's going to pull alternator, and also the refrigerator, it's showing it's up. So now we're up to 13.3 volts. And so that tells me that the battery back here is charging. You can also see on the refrigerator here to where it's showing that the voltage is back at the 12.8. Nothing has changed here except for the vehicle is now running. The vehicle is charging the battery and it's putting out enough amperage and voltage to carry the load plus charge it. That's why having a 40 amp DCDC charger is kind of important, because you need to have a high enough amperage charger to make sure that you can charge that battery up as quick as you possibly can. So if you're only traveling a couple hours, can you fully charge that battery within a couple hours? The thing is, remember, I mean, unless you got a massive voltage draw on a battery, you're never really going to pull the battery all the way dead, unless something crazy happens and you just got something going on that's not out of the normal. But on average use like this, is just run the refrigerator. That battery right there is going to run that refrigerator for at least 2 days without any input. Different refrigerators pull different wattage or watt hours, so you definitely need to make sure that your system can handle however big a refrigerator, freezer you're running. But other than that, I mean, honestly, you're really never going to have the battery less than half percent using it normal, and that's on a hard uses on 100-something degree night, and that refrigerator is running a lot. So really, you know, you're only charging up for 50%. So we have yet to have a problem with the 40 amp yet, charging it up between stops, because we do a lot of overland. We'll stay for a night, take off, and then drive the next day. By the time we get where we're going, 2, 3, 4 hours later, 8, 10 hours later, battery's fully charged. We're good for the night, and we're ready to start again. So guys, I hope you guys enjoyed this video. If you have any questions, let me know. If you liked it, you know, go down and like the video. If you're not subscribed and you want more content like that, go ahead and subscribe, share the video. Let us know what you think. If you have any questions, let me know. I'll answer them the best we can. We respond to all of our comments. And guys, we got more videos here. Go check them out. And until then, we'll see you on the trail.